our prior question. Let me go turn our poll back on. Okay, so tell me what you think. So in this configuration, which one is going to be the brightest? Okay, so here's our votes. So indeed, A is the brightest now, because let's figure out what our different vectors are. So this is a light vector. This is my reflected vector. Well, let me get a normal first. This is my normal vector. So therefore, this is my reflected vector over here. And this is my eye, or sometimes a viewing vector. And what I care is this R dot E. And since they're lined up, this dot product is going to be 1. So here, what's the reflection vector here? So the reflective vector here is just back, because that's where because it's around the normal. Here, this is the reflected vector. Let me just pull out of the way. Here, this is the reflected vector. So I'm checking this angle, I'm checking this angle, checking this angle. So this is the smallest angle, so it's going to have the highest dot product or cosine. It's going to have the smallest cosine, or the smallest theta, largest cosine, largest for doing the dot product. Questions about this specular term? Okay, I don't see any questions about specular. There was a question earlier about, does the brightness have to do with the light temperature? So when we talk about light temperature, you typically see this for light bulbs, right? They talk about, oh, it's a 2700K yellowish light, or it's a 4000K bluish light. This is really about the color of the light. So that temperature is because different objects burn with like objects heated to different temperatures have different amount of color of light coming off of them. So this, you would, if you want to do light temperature, you would change the lighting coefficient that says what color is your light. So in this equation, this term is my lighting color. We have the same term in the diffuse. So I would set my color to be slightly more yellowish or more bluish if I wanted to change the lighting temperature.